Hello and welcome to the Sound on Sound recording and mixing podcast channel. I am Eddie Bazil. Dynamic equalizers are the new faux compressors of our times. They're far more versatile than static equalizers, more flexible than multiband compressors, and are perfect for both corrective and coloring tasks. In this podcast, I'm going to demonstrate how to use dynamic equalization to correct and color specific sound sources, most notably drum beats, vocal lines, and entire mixes. But before we jump in and get creative with this wonderfully powerful dynamic, let us explore what dynamic equalization is and how it works. A dynamic equalizer functions much like a static equalizer, but adopts certain compressor functions, most notably threshold and attack and release. A dynamic equalizer applies the gain change directly to the gain parameters of a multiband parametric equalizer. As with most dynamic processors, the threshold determines at which point gain changes take place, be they compression or expansion or both. You have control over the bandwidth, denoted by the Q value, and much like a compressor, the compression, expansion response and behavior is controlled with the attack and release functions. Think of dynamic equalizers as multiband compressors on steroids. However, there is a distinction between the two topologies. Whereas multiband compressors use crossovers, dynamic equalizers utilize all the traditional filter shapes along with bandwidth control. And these simple distinctions gives the latter more precision and control over the audio being processed. Example 1 delves into the world of frequency-conscious sidechaining and beautifully addresses the age-old kick-bass interchange problem where simultaneously triggered shared frequencies are fighting for space. Whereas traditional compressor sidechaining will afford both internal and external sidechain filtering, dynamic equalizers take this process to a whole new level and allow for very precise frequency ducking. Using the wonderfully detailed and musical Tokyo Dawn Labs Nova GE dynamic equalizer, it is a doddle to hone in on the exact frequencies that need ducking. Here is the dry, unprocessed version. And now with the TDR GE. Switching the equalizer's analyzer to display the incoming sidechain trigger's response, in this case the kick drum of a beat, helps greatly in sculpting the ducking response. Using a bell with a Q value of 2.65 and adopting a conservative threshold of -9.5 dB, stationed exactly at the apex of the shared frequencies of 55 Hz, the dynamic equalizer makes light work of ducking the bass frequencies to allow the kick to shine through when playing together. The compression-expansion response can be further shaped with the attack and release functions, and in this example I've timed them against the start end of the kick drum. In the second example, I'm going to process a drum beat using the Waves F6 dynamic equalizer. The aim is to add some weight to the kick drum whilst adding motion to the percussive bed. Here is the dry, unprocessed audio. And now with the F6. The Waves F6 is a potent dynamic equalizer and comes laden with the usual functions you'd expect to see from such a detailed tool. It is simple to use and can behave quite musically, and is equally adept at performing corrective tasks. The trick in processing individual drum elements within a drum beat is to isolate the prominent fundamental frequencies that make up each drum element, and to treat them first in isolation and then referenced against the entire beat. The solo function helps greatly in isolating each drum sound. I have applied some hefty expansion to the kick element by making sure to encompass the whole range with a threshold value of -45 dB. This has then been expanded to the maximum value offered by F6 of 18 dB. A Q value of 2 makes sure to capture the kick's range without it overlapping onto the adjoining frequencies. I have applied generous expansion to the 16 kHz region, where most of the percussive elements reside. Using a broader Q value has ensured I grab most of the frequencies around this range, but a cool trick I've adopted is in using compression to attenuate frequencies just prior to this range to scoop out specific mid-range frequencies so as to further highlight the higher frequencies. This is known as the Pultec trick. The overall result is a more pronounced kick element that bounces along on a flowing and vibrant percussive bed. Example 3 demonstrates how dynamic equalization can be used for corrective tasks. I'm sticking with the mighty TDR Nova GE and I've set the equalizer up so as to remove vocal resonances that are evident across the frequency range. The advantage of using dynamic equalization for removing resonances is that once the resonances have been attenuated, the treated bands can jump back up to their normal state as determined by the compressor's release value. This affords a more natural response than a static cut. Here is the dry version. And here is the processed version. The trick with removing resonances is to make sure that the process sounds natural. This is achieved by using gentler thresholds and lower ratios for all the bands that are set to compress. Narrow Q values help to notch only the offending frequencies and not any critical crossovers that could otherwise mar the response. I have used a combination of de-essing managed by the final band of 4 set to compress at 7.8 kHz and adopting the internal sidechain filter at the same frequency but with a very narrow Q, and specific resonance attenuation using 3 additional bands set to 926 Hz, 1.62 kHz and 3.2 kHz respectively. It's not an accident that these frequency values almost sit in the harmonic series, as you tend to find that a single resonance can be repeated and accented across the octaves. The result is a smooth response across the whole spectrum. Example 4 follows on from example 3 and incorporates the vocal line within a mix context. I will be using a segment of the mix to save time and space and show you how to use expansion to highlight specific frequencies within a mix. The aim is to afford motion across the whole spectrum and to highlight the reverb ambience whilst managing levels. Here is the dry version.
He'll be driving you insane. He'll become your weekend lover. Then he'll blow you out again.
And now the processed version.
He'll be driving you insane. He'll become your weekend lover. Then he'll blow you out again. But you go there anyway.
When dealing with a mix, the entire response has to be considered as a whole. as opposed to highlighting frequency segments, and it is here where bandwidth reigns supreme. Special attention has to be given to all filter slopes, as any processing on one band will invariably cross over and influence adjoining bands. With the exception of one band that uses a narrow Q for attenuating a problematic resonance at 372 Hz, all the other bands, and there are 5 additional bands, adopt gentle and wide Q values. Varying thresholds with different attack and release times guarantee that the bands all behave slightly differently to each other. This allows for motion, and it is motion that reigns supreme with all mixes. The brain likes gain variances across frequencies, and we strive to continually trick the brain into evaluating new incidents that, once summed, lend themselves to an interesting and vibrant response. All 5 bands adopt very gentle expansion settings. The aim is to lift specific segments of the mix and to highlight the airband and high frequency tails of the reverbs. And this is achieved with a bell that has a fast attack and release expansion setting. The overall response is smooth, more open, and has a lovely top-end sparkle that doesn't translate across as bright. Example 5 involves taking a wonderful trio a cappella and opening the sound up a little more so each of the 3 voices can be heard clearly. First, the dry version.
Oh, I may not tell you, says Vessel to foes, with bows and with arrows, says John the Red-Nosed. With bows and with arrows, says John the Red-Nosed.
And now the processed version.
Oh, I may not tell you, says Vessel to foes, with bows and with arrows, says John the Red-Nosed. With bows and with arrows, says John the Red-Nosed.
I find that with well-sung and recorded a cappellas, it is important not to apply any drastic processing, as these will stick out like a sore thumb. It is far more important to keep the flow and direction of the piece intact. Managing frequency gains and removing resonances goes a long way in prepping content for mastering, but to master for a medium or genre, flow is far more important. And, as before, to keep the brain interested, slight gain changes at specific frequencies can work wonders. I'm sticking with the wonderful TDR Nova GE dynamic equalizer, and before any decisions are made as to what needs doing where, a brief analysis of the entire spectrum helps in locating where redundant and problematic frequencies lie. With the exception of the standard 20 Hz cut, I found no audible anomalies that needed heavy lifting. However, separation with gentle Q values and frequency gain modulation with slight expansion is all that was needed to open this mix and highlight the 3 distinct voices. Almost all mixes, be they entire musical pieces or a cappellas, have problematic mid-ranges that can congest the mix and cause all manner of frequency clashing, masking, and summing. The mid-range of a mix is where most of the energy lies, and when dealing with a number of vocalists, it pays to study the interaction of all the vocal frequencies within this critical range. With this in mind, I decided to use 2 bands dedicated to interchange between 2 critical frequency ranges, 643 Hz and 736 Hz respectively. In effect, both bands expand at different minimum and maximum values and at slightly different times as governed by the threshold and attack and release settings. This highlights different areas of the sung vocals and comes across as separation. 72 Hz and 3.3 kHz are also expanded to pronounce the 2 male and 1 female vocal at those critical frequencies. All other bands have been reduced in gain but expanded so as to rise from rest to expansion maximums. The mix comes across as more open and vibrant. In the 6th and final example, I'm going to use Gullfoss, a dynamic and adaptive equalizer that uses dark magic to intelligently analyze and equalize complex material. I will use it to highlight certain aspects of a well-mixed R&B song. Here is the dry, unprocessed version.
Waiting on you, baby. I've been missing you all day. keep away from me. That body got me vibing. Are you ready to receive my love? I want to take it all. Never been so good, just giving love without expecting none. Pop it, drop it, pop it, and the night is coming up tight, it's cold. You'll see the stars appear across the sky for your love. We both deserve this feeling, I want you to know.
And here is the processed version.
Waiting on you, baby. I've been missing you all day. How could you keep away from me? That body got me vibing. Are you ready to receive my love? I want to take it all. Never been so good, just giving love without expecting none. Pop it, drop it, pop it, and the night is coming up tight, it's cold. You'll see the stars appear across the sky for your love. We both deserve this feeling, I want you to know.
The song is well balanced, but could do with some tweaking to highlight certain transients and offer better separation of all the elements within the mix. Galfox is designed to be both fun and intuitive to use. It teases you to grab all the knobs and turn them to hear what happens. However, don't let this fool you into thinking it's a, let's have some fun plugin. On the contrary, it is a professionally conceived and designed audio-enhancing weapon that can work magic on all sounds, although it excels at correcting and optimizing full mixes. The parameters on offer range from unmasking frequencies to taming dominant frequencies, balancing low and high frequencies, and I'll stop there and let you read the manual, as this plugin does far more than just equalize. I have followed Galfox with a limiter so as to further highlight what it is doing. I find placing a limiter after a mastering equalizer helps to hear detail and allows for corrective control of any anomalies that might creep up as side effects of pre-limiting processes. The best way to use Galfox is to start with the first function, recover. Make adjustments, listen, tweak, and then move on to the next function, tame, and so on. The reason behind this order of processing is that each function has a dramatic effect on the ensuing function, and you will find that you will constantly go from function to function tweaking until you achieve the desired result. The entire process is very intuitive and takes you away from the analytic processing that static equalizers usually require. I settled on the following: recover, 39%, tame, 22%, bias, 56%, which favors recover, brighten, 9%, and boost, 3.3%. I tend to leave brighten until after I have settled on all the other parameter values, as brighten is strongly influenced by the boost value. I opted for more recover than tame, and further endorsed this by using a strong positive bias value, as I felt some separation was needed between the kick and bass and some of the vocals. However, I decided that by leaning towards unmasking certain frequencies, a modicum of tame was also needed to pull back on any strong transients that were exposed through the recover process. A small boost value helped to highlight the low frequencies, and I compensated for this by using a small amount of brighten. The combination of the two has afforded a more balanced and clearer response. For the limiting, in the event you want to replicate my settings, I have used Ozone 9's Maximizer. For mode, I selected IRC1, ceiling set to -0.1 dB, threshold at -4.5 dB, and character set to fast, setting of 1.18. These settings allow for the maximizer to react quickly to transients but slowly for bass sounds. This results in a tight and smooth overall response. That's it for now. Thanks for listening. This has been Eddie Bazil for Sound on Sound.
Thank you for listening, and be sure to check out the show notes page for this episode, where you'll find further information along with web links and details of all the other episodes. Oh, and just before you go, let me point you to the soundonsound.com/podcasts website page, where you can explore what's playing on our other channels.